Today's topic is probability mass function. In short, we can write PMF, or it is also known as discrete probability distribution. Now we can see the definition. The probability mass function of a discrete random variable x is a list of possible values of x together with their probabilities. And that is can be written as f of x equal to p of x, which is equal to p of x equal to small x. Yes, capital X is the random variable and small x is the values that capital X takes. And there are two conditions for probability mass function. First one is probability always lies between 0 and 1, and the total probability always equal to 1. It is sigma x p of x equal to 1. Now we can discuss some questions based on probability mass function. Now the first question, write down the PMF for the random variable x, which gives the number of heads in tosses of two coins. So before starting this question, what is the sample space of this? When we toss two coins, what will be the sample space? We denote sample space by the letter capital S. We know that sample space is the set of all possible outcomes. Here, what are the possible outcomes? H, H, T, T, H, T, T, H. These are the possible outcomes. Now, what is the question? You have to write the PMF. What is PMF? PMF is the list of all possible values of the random variable with their probabilities. So, what is the random variable here? Here, the random variable x is the number of heads. Now we can write what are the values that x takes place. Number of heads. The first outcome, number of heads is 2. In the second outcome, number of heads is, what is number of heads? 0. Third outcome, number of heads is 1. So we know that we can write it nicely, that is 0, 1, 2 are the outcomes. Now we have to write the probabilities, corresponding probabilities. So outcomes are HH, here is 2 heads, then TT 0 heads, HT, TH 1 heads. So the values that the random variable takes are 0, 1, 2. Now we have to find the corresponding probability. Now what is probability? Probability is equal to number of favorable outcomes divided by total number of outcomes. Here the total number of outcomes is 1, 2, 3, 4 outcomes. Total number of outcomes is 4. In the first case, number of favorable outcome is 1. That is TT. That is the corresponding probability is 1 by 4. Total outcome is 4. So that is 1 by 4. In the case of 1, there are 2 possible outcomes, HT and TH. So 2 by 4, that is 1 by 2. In the last case, 2 heads, only one possible outcome. So this is 1 by 2. Now this is the probability mass function. This is the probability mass function. You can write it as a table form, or you can write this as, you can write P of capital X equal to small x equal to, what are the probabilities? 1 by 4, then 2 by 4 and 1 by 2. 2 by 4 can be written as 1 by 2. So 1 by 4 and 1 by 2. 1 by 4 when x equal to 0. 1 by 2 when x equal to 1 comma 2. So this is 1, not 1 by 2, this is 1 by 4. It is 1 by 4 when x equal to 0, 2, 1 by 2 when x equal to 1. So we can write like this. Now next problem, find the value of k from the given PMF. Here PMF is given, you have to find the value of k. So we know that probability always should be lies between 0 and we have two nodes. Probability should be lies between 0 and 1 and total probability always should be equal to 1. So from this we can write k by 2 plus k by 3 plus k plus 1 by 3 plus 2k minus 1 by 6 equal to 1. Okay. So adding these should be equal to 1 because probability, sum of probability is always equal to 1. So you can take the LCM. So this becomes 3k plus 6 plus 2k plus 6 plus 2k plus 2 by 6 plus 3k minus, not 3k, 2k minus 1 by 6 equal to 1. Now adding and subtracting this, you will get 9k plus 1 by 6. That is 3k plus 2k plus 2k plus 2k, that is 9k. 2 minus 1, that is plus 1 equal to 1. From this you will get 9k plus 1 is equal to 6. Then you can write 9k equal to 6 minus 1, that is 9k equal to 5. From this you can write k equal to 5 by 9. That is the answer. Okay. Now next problem. Given that p of x equal to k by 2 raised to x is a probability distribution for a random variable that takes values x equal to 0, 1, 2, 3, 4. Find the value of k. So here probability distribution is given, that is p of x equal to k by 2 raised to x, and it is given that x equal to 0, 1, 2, 3, 4. These are the values that x takes. Now you have to find the value of k. So we know that x takes the value 0, 1, 2, 3 and 4. So what will be the corresponding p of x? We know that p of x equal to k by 2 raised to x. So this becomes k by 2. K by 2 raised to 0 is k by 2. K by, sorry, 2 raised to 0, that is k. 2 raised to 0 is 1. So k, k by 2, k by 4, k by 8, k by 60. So this is the probability mass function. First one is k by 2 raised to 0, that is k. Then k by 2 raised to 1 is k by 2, so on. Now you have to find the value of k. So we know that the sum of probability sigma x p of x is always equal to 1. So we can write k plus k by 2 plus k by 4 plus k by 8 plus k by 16 is equal to 1. So you can take k outside. So 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. Now you can use calculator to solve this. Then you will get K is equal to 16 by 31. Okay, do the calculation yourself. You can take reciprocal, or you can take reciprocal method, or you can use calculator. Now next, fourth question. This is the last question. Using the PMF, find probability that at most 2, probability that 2 and 5 inclusive, probability that strictly between 2 and 5, probability that at least 3 are in use. So I will write the probability mass function here. X equal to small x. X takes the value 0, 1, 2, 3, 4, 5 and 6. Then corresponding probability is also given 0.05, 0.1, 0.15, 0.35, 0.1, 0.15, 0.1. So probability mass function is given in the question. So you have to find out the answers of each question. Now look the first question. Probability that at most 2. At most 2 means maximum is 2. Maximum is 2 means the first question. P of at most 2. Probability that at most 2 is maximum is 2. So P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2. Maximum 2. So minimum is 0. So you can write this as P of 0 plus P of 1 plus P of 2. So what are the corresponding probabilities? P of 0 is 0.05 plus 0.1 plus 0.15. So add the probabilities and you will get answer as 0.3. Now second one, probability that 2 and 5 inclusive. 2 and 5 inclusive, you can write this as probability that 2 less than or equal to x less than or equal to 5. So you can write P of x equal to 2 plus P of x equal to 3 plus P of x equal to 4 plus P of x equal to 5. So this is equal to P of 2 plus P of 3 plus P of 4 plus P of 5. So this is equal to, write the corresponding probability. P of 2 is 0.1, P of 3 is P of 2 is 0.15, P of 3 is 0.35. So add the corresponding probability, that is P of 2 is 0.15 plus P of 3 is 0.35 plus 0.1 plus 0.15. So when you add these values, you will get answer as 0.75. Okay. Now third question, probability that's strictly between 2 and 5. Strictly between 2 and 5 means P of 2 less than x less than 5. That is 2 and 5 is not included. So what is the value P of x equal to 3 plus P of x equal to 4. So that is P of 3 plus P of 4, that is equal to 0.35 plus 0.1, that is equal to 0.45. Now last question, probability that at least 3 are in use. At least 3 means minimum is 3, maximum can be Here it is 6, maximum is 6. So minimum is 3 and maximum can be 6. So P of at least 3 means P of x greater than or equal to 3. So this is equal to P of 3 plus P of 4 plus P of 5 plus P of 6. So when you add these probabilities, you will get answer as 0.7. So that's all about probability mass function. Thank you all.